In this series of videos, we would be solving a few problems on piston-based pumps. You might have seen this kind of a system in your everyday life. So look into this picture over here. There is a cylindrical shaped space, okay, this white color portion where you can put some fluid inside. And there is a piston. This blue color dashed object is a piston which can move within the cylindrical shaped object, okay. So if you push this piston towards the right and if you have some fluid inside, what would happen? That fluid would come out of a small hole which is over here. So this is a piston pump. Now we would be solving a few cases of this piston based pump. So the first case that we are going to solve is that we have a fluid inside this pump initially. The density of this fluid is, let's say, rho. Few more information is given to you that the cross-sectional area of this small hole is, let's say, A1, and the cross-sectional area of the piston, okay, the piston is a three-dimensional object, right? So it has a cross-sectional area which is this area, basically this area, okay? So that cross-sectional area is, let's say, A. Now A is much more than A1, okay? Now what is done is a force F is applied onto the piston from this side, okay? The total volume of fluid inside this piston is equal to V. What you have to find out first is how the velocity of the fluid coming out of this small hole varies, okay? You have to evaluate the velocity if you can. So you have to find out what is the velocity with which the fluid would be coming out and how it varies as the piston moves towards the right. So find out velocity. Second, you have to find out what is the amount of work done in pushing the entire fluid out of this piston. Another information that has been given to you is that the total time taken to push this fluid out of the piston is T. So the volume of the fluid is given, the time taken to push the fluid out of the piston is given, which is T. The density of the fluid is rho, the cross-sectional area of the piston is A, the cross-sectional area of the small hole is A1, and you are applying a force F. This force F is constant. Under the given information, you have to find out what is the velocity with which the fluid would be coming out. You have to find out if it varies as the piston moves towards the right. You also have to find out what is the total work done in pushing the fluid completely out of the piston. The third thing you have to find out is what is the minimum force, okay, if you need to apply so that the fluid comes out. Just applying any force would not push the fluid out of the piston. You have to apply at least a minimum force. You have to find that minimum force out. Okay, so this is case 1. We would be solving case 1 in the follow-up video. Let me state case 2 also. So case 2 is this entire system is kept inside a container containing some other fluid, okay? So there is a container containing some fluid which has a density of, let's say, rho 1, and the piston along with this fluid is kept inside it. Okay, so inside the piston and the cylinder, okay, of course there is this original fluid which has a density of rho. All other information remains same, that is the force F that is applied, density of this fluid, the cross-sectional areas, the volume of the fluid, everything is same. For this condition, you have to find out how the velocity varies, okay, as the piston moves towards the right. You also need to find out what is the minimum force that you need to apply so that this fluid comes out, this blue colored fluid comes out of the cylindrical shaped this pump, piston pump. Okay. Now one more information that has been given to you is that the piston is kept at a depth of h. Okay, the hole from where the fluid will be coming out, that hole is at a depth of h from the surface of this fluid. Okay, this is case 2. Next, you have to solve one more case, which is case 3. In case 3, the piston along with the cylindrical shaped pump is taken in a vertical position, something like this. Okay, the same constant force F is applied, the same fluid is inside, the cross-sectional area is same, that is A1. What you have to do over here is you have to find out how velocity varies as the piston moves up. Okay, so let's say initially the piston is at a depth of h. You have to find out what happens when the piston has moved up and the depth of the piston from the top. Okay, the difference in length, the difference in height between this hole and the piston is, let's say, y. You have to find out how the velocity varies, and also you have to find out what is the total time taken to push this fluid out of this cylinder. Okay, let me tell you that the second part of the problem where you have to find out the time taken, it's a little bit mathematical, so we would not be solving the entire mathematics out of it. Integration would be formed and we would leave the solution over there. You can try to solve the integration if you wish. So these are the 3 problems that you need to solve where this cylindrical shaped pump having a piston at one end is there. Okay, so basically 3 cases, and in the follow-up video we would be solving case 1, which is the simplest one. Thank you.